Hello and welcome back to Precalculus1 from home and your homes, I guess. Well, we are going to take a look at the long division of polynomials, remainder and factor theorem for today. So I will be continuing the course online, and I am hoping that you guys will type something in chat just so I can see that you are here and that you are able to communicate. So type something in chat if you can hear me. You should be able to hear me because I already had 2 classes today. So, hello. Okay, so it should be good. So, for the remainder of the semester, unfortunately, the college is closed. So we will have to do this, and then you can find the videos in the playlist. So, let's talk about dividing polynomials. But before we divide polynomials, we are going to divide numbers, long division of numbers, and then we are going to use that to see that polynomials have exactly the same method. So let's divide, say, 13 into 4,891, whatever. So that's where we start. We start by dividing 13 into 4,891, and if you know this, then the other one is going to be easy. If you don't know this, then you learn this first, and then the other one is easy. The other way really doesn't work. So let's go and see what we can do. Hello, everyone. You can type your questions in the chat, and then I will stop to answer those. If you are watching live, obviously, the videos will stay on the channel just like they stayed before. And please keep checking, hello. Please keep checking Canvas for announcements and your emails for announcements, regarding the rest of the stuff. We need to have an exam after chapter 2. So 3 sections, right? All right, let's talk about this. So 13 in 48 goes 3 times, because 3 times 13 is 36, and then we subtract, we get 12. Then we drop down a 9, which is the next digit. So we are going to now say 3 times in 129. Well, 13 times 10 is 130, so this must be 9, right? 9 times 13. That's 9 times 3 is 27, 9 and 2, 11. There we go. So subtract again. So we always do the same method. You see how many times 13 goes into a number, then you multiply it back and subtract. So last digit we have to drop down 1. So now we have 121. Well, it's going to be 9 again, because 9 times 13 is going to be 117 again, with a remainder of 4. We do not divide decimals here. We don't need them because we actually need the remainder. So I'm just going to say R4. So if you divide 4,891 by 13, you will get 399 with the remainder 4. Now, obviously, you can use the calculator to check this. The algorithm is going to be the same whether you use numbers or you use polynomials. So 13 goes into 48 3 times. 3 times 13 is... 3 times 13 is not 36. It's 30. Yeah. I should restart the whole lecture now. 3 times 13 is 39. From scratch. Well, welcome to the new semester. Excellent. Let's go from scratch. 3 times 13 is 39. All right, so 13 into 48 goes 3 times. 3 times 13 is 39. Not 36, 39. There we go. So now we subtract. That's the minus over here. So we get 9. Then we drop down 9 and we have 13 into 99. Maybe 7. Try 7. 7 times 21, 91. Perfect. Subtract. We get 8. Drop down 1. Okay, so that has to be 6 because the 7 gave us 91. Then 6 will give us less than that. So 6 times 3 is going to be 6 times 3 is 1878 over here. And when we subtract, we get remainder of 3. Much better. So 4,891 divided by 13 is going to give us 376 with the remainder 3. Now, if you have numbers that are harder to divide, you can make multiplication table on a side and use the numbers from that multiplication table so you're not making the mistakes like I do, right? So let's get some larger number. Say you have, I don't know, 28 divided in 53,861, whatever. We can literally put anything. Now, instead of breaking my head on what goes how many times and all that stuff, I'm simply going to make multiplication table for 28. And that's done very easily just by adding all of the numbers. Those of you getting in a little bit late, that's great because you missed my terrible mistake at the beginning of the class. So now I'm going to work double hard to make sure I'm not making any more mistakes over here. Anyway, so let's make multiplication table. So we start 28 plus 28 is going to give us 56. Now see, 28, that was for times 1. This is for times 2. Right, 28 times 2. Now we add another 28 over here. That is going to give us 84. So that's 28 times 3. Then you add another 28. So that's going to give us 112. That was 4 times 4. And when we add another 28, we will get 140. And that's times 5. Then we are going to add another 28. That's 168. That was the times 6. Add another 28. That will be 196. That's times 7. Add another 28. That's going to be 422. There we go. So that's times 8. Add another 28 over here. 252. That's times 9. And plus 28, this one must line up every time. That's 280, which is times 10, and that's what you check, right? Because 28 times 10 is 280. So now I have my multiplication table for 28. That's 1, that's 2, that's 3, that's 4, that's 5, 6, 7, 8, 9, and 10. I have these 10. So now it's going to be easy. 28 into 53. Well, 84, that's bigger. 56, that's bigger. So I can't use any of those. So it goes once. Subtract 28. So you steal 1 from 5. You get 13 minus 8 is 5. And then 4 minus 2. And then we drop down the next digit, which is 8. 258. Well, I have 252. That's great. So 9, 252, subtract. We get a 6. Drop the next digit down. That's a 6. How many times goes into 28 into 66? Well, 56, right? Because next one is 84, so goes 2 times. 2 times 28 would be 56, and we get 10. Finally, drop the last digit down for 101. 112, so 84 has to go 3 times for 84. It's 84. That looks like a 9. There we go. And when I subtract, I get 7 and 1. Remainder 17. You always make sure that your remainder is smaller than the number you're dividing by, otherwise it won't make sense. So this algorithm is something that you learn in elementary school, right, for division of numbers. And we are going to use exactly the same division algorithm to divide polynomials today. So let's learn division of polynomials using absolutely same algorithm. The goal is to divide, let's say, x plus 2 into x cubed plus 6x squared plus 7x minus 9. We can make up literally anything. It doesn't matter. So if I write the polynomials and I need to divide, I'm going to look how many times this goes into there. So how many times x goes into x cubed? Well, we can do that on the side. X cubed divided by x is x squared, so it goes x squared times. Now, just like in regular numbers, you take what you got and you multiply into the polynomial. So when you do that, you will get x cubed plus 2x squared. We put that in parentheses and subtract, just like what we did for numbers, right? You subtract when you multiply back. So we multiply when we subtract, the first one will cancel, and you have 6x squared minus 2x squared to give us 4x squared, and you just copy the rest of the polynomial. Now we repeat the procedure until we're done. How many times x goes into 4x squared? Well, 4x squared and then x on the bottom is just 4x, positive 4x. So plus 4x. You have to have a sign in between these two terms. So it's either plus or a minus. Okay, now that you have your 4x, you will multiply 4x into the polynomial here. Will give us 4x squared plus 8x, because you distribute this one into both. Once you multiply back, you will put the parentheses and subtract. The first two guys again cancel, and you have 7x minus 8x is negative 1x, or just negative x minus 9. Now the last step, how many times x goes into negative x? Well, divided. Negative x divided by x is negative 1. So minus 1. And now you use that negative 1 to multiply the entire polynomial here. We get negative x minus 2. We subtract. Be very careful, a lot of signs floating about. We get these first guys cancel, right? Because you are always subtracting the same numbers on the first, same terms on the first one, right? And now we have negative 9 plus 2. This minus and this minus make positive, right? So negative 9 plus 2 is negative 7, and that's the remainder. Now, in algebra, we can write the remainder in terms of the fraction. So it's going to be minus 7 over x plus 2. And that is the answer. So we divided and we got x squared plus 4x minus 1 minus 7 over x plus 2. That is the answer when we divide two polynomials. Let's do two more examples of this, just in case, and you can keep reviewing these. If I'm going to quickly, just you remember, you can always rewatch the video. It stays on the channel, and you can pause it, right? You can go back and skip around. So don't panic. The next example, we are going to take something that I don't know if I want to say divides nicely or something, because it's not divides nicely, it divides without remainder. So how about we take a look at the homework example 6. I hope if I did this correctly. Let's see. So we are dividing, so the problem is posed this way: 6x cubed plus 17x squared plus 27x plus 20 divided by 3x plus 4. So this is exercise 6 on homework. And what you do is you put it in a form for division, and then we go and work the algorithm. So we have our 3x plus 4, and we have our 6x cubed plus 17x squared plus 27x plus 20. Always the same. How many times this goes into that one? So you're always looking at the first ones, which we call leading terms, right? The ones with the highest exponents. So we go on a side and we say 6x cubed divided by 3x. 6 and 3 cancels down to 2x squared. So the first one is 2x squared. So you can always bring the 2 on a side and do the algebra there, divide them, and then bring the answer on top. Once you have answer on top, you are multiplying back into both. So we have 2x squared times 3x is going to be 6x cubed. They better match. Every time they better match. And then plus 8x squared. So now we put the minus there. We subtract. The first one always better cancel. And the second one over here is 17 minus 8, which is 9x squared. And then we copy the rest of the problem. You are done with the first one. So repeat the procedure. How many times 3x would go into 9x squared? Well, here's 9x squared divided by 3x. 9 divided by 3 is 3. X squared and x cancels down to x. We have positive 3x. Positive 3x. And now we take that positive 3x and we distribute into both. So 3x times 3x is 9x squared. 3x times 4 is plus 12x. We put in parentheses and we subtract. 9x squared minus 9x squared is 0. That cancels. 27 minus 12 is 15. X plus 20. You always drop down the rest. And we are now at this last step where you ask yourself how many times 3x goes into 15x. Do that on the side. Again, we have our 15x divided by 3x, which goes 5 times. So plus 5. And now we multiply back that 5 into both of these. 5 times 3x is 15x plus 20, and now when I subtract, they both cancel and we have no remainder this time. So this divides without remainder, and you found two factors. So now if you're interested, you can check real quick by multiplying the two factors you got, so you can bring back the original problem. So let's see. 2x squared plus 3x plus 5 times 3x plus 4. And you know what you need to do. You need to distribute 3x into all three and 4 into all three, and then add like terms. So now 3x gets distributed into all of these. So I'm getting 6x cubed plus 9x squared plus 15x. And then we are taking 4 into all three of these. So that's going to be plus 8x squared plus 12x plus 20. And now what we do is we collect like terms. 6x cubed has no like term. 8 and 9, that's plus 17x squared. 15 plus 12 is plus 27x plus 20. And as you can see, that's exactly what we had when we started. So polynomial division is an algorithm that is exactly the same as the algorithm you guys had for dividing regular numbers. You check how many times x, or whatever you have, 3x in this case, goes into whatever term is the highest exponent, and then you work out algebra on the side, multiply it back, simplify, subtract, simplify, and then bring the rest of the polynomial, and then rinse and repeat. Now, some problems will have gaps, and we need to deal with that as well. Here's number 15 is a perfect example of that, because they're asking you to divide 18x to the fourth plus 9x cubed plus 3x squared by 3x squared plus 1. Notice that you do not have all of the exponents present. This is problem 15. There is no x term here. There is no x term here, and there is no constant term here. So what you can do is you can fix that by plugging in what we call placeholders to have all of the terms. You don't have to do it. If you're careful enough, you can just line them up where they need to go, but it's easier if you do this. 3x squared, and here is a placeholder, plus 0x, and then plus 1. So this is still our polynomial that was in the denominator. That divides into 18x to the fourth plus 9x cubed plus 3x squared. If you really want to, you can add plus 0x plus 0, but they really don't matter at the end. And now it's the same procedure as before. How many times 3x squared goes into 18x to the fourth? So it's always the same procedure. If you have any missing in either spot, just fill them in with zeros. So what we have on the side is 18x to the fourth divided by 3x squared. 18 divided by 3 is 6. And then we have x squared, so the first one is 6x squared. Now, we are going to multiply those back into, well, to all three of these. So we get 18x to the fourth plus 0x cubed, because 6 times 0 is 0, and then plus 6x squared. Note that they're all lined up perfectly. When you subtract, the first one will cancel as usual, and we have 9x cubed minus 0, that's just 9x cubed, plus 9x, no, lies, minus 3, because 3 minus 6 is negative 3. There we go. And if you really want to, you can put plus 0x plus 0. You don't have to, but you can. Now, you ask yourselves, how many times 3x squared goes into 9x cubed? So that's 9x cubed divided by 3x squared is going to be 9 divided by 3 is 3, and we just have an x, and it's positive. So plus 3x. And multiply back, remember. So this one now goes into all three over here. So we have 9x cubed plus 0x squared and plus 3x. Now remember, if you had 0x here, they're lined up. If you didn't, don't worry about it. Subtract. The first part will cancel. Then I have minus 3x squared minus 0. Well, that's still minus 3x squared. And then I have minus 3x. Minus 3x. One last time, we are going to divide. Right? One last time. Because we already have the same exponent. So you can't go past that. Right? So, how many times 3x goes into negative 3x squared? So that's negative 3x squared divided by 3x, and that's just negative 1. So minus 1. Note your answers here, x squared, x, and then the constant. They always drop by 1 as you move along. Okay, so now multiply back. Negative 1 times 3x squared is negative 3x squared. Negative 1 times 0x is still 0x. And then minus 1 at the end, and we subtract. These guys cancel. Then we have our negative 3x minus 0 is still negative 3x. And we have now plus 1, because this is technically a 0 here, minus, and a minus will make a plus. So 0 plus 1 is 1. That's the remainder. So we would write that one in the answer as 6x squared plus 3x minus 1 plus negative 3x plus 1 over 3x squared plus 1. And this would be the answer. The question is, how's that negative 3x? Okay, I will explain all of the 3x's that I see here from scratch. So over here, I multiplied 3x into a 1 to get positive 3x, so that's good. Now, over here on top, I had plus 0x. So 0x minus 3x is negative 3x. So I have negative 3x there. And then negative 3x, right? Negative 3x minus 0 later is still negative 3x. I hope that made sense. So there was a 0x here. When you subtract 3x from 0, 0 minus 3 is negative 3. And then later on you will be adding a 0 to it, so it remains negative 3x. So I hope this is okay. Please, rewatch the video if it doesn't make sense. Now I just need to make sure that you guys are understanding the answer. One of the frequent mistakes is putting this negative here. That's not good. You can, but you also have to change this sign then. So you have to be very, very careful. I will write the other answer, but again, it can be an issue. So if you put a minus here, then this becomes 3x minus 1 over 3x squared plus 1. You see, this sign changed as well, because if I am to multiply this sign in, then this would become negative and this would become positive, and I need it to be positive. So you have to be very careful if you want to put the minus there. I don't care which answer you present, but the signs have to be correct in the remainder part. Now the question is, how do you check? How do you check the remainder with the remainder? Well, you will multiply back the polynomial, and then you will just add the remainder into the procedure. So if you care, right, if you want to check, you will take your 6x squared plus 3x minus 1, and you will multiply that by 3x squared plus 1, and then you will add negative 3x plus 1 when you are done with multiplication, but you have to multiply first. So we have 18x to the 4th, right? We have this one going all three ways, plus 9x cubed minus 3x squared plus 6x squared plus 3x minus 1. And now we have minus 3x plus 1. When we add all of the like terms, we should get our original problem. Let's see. We have 18x to the 4th plus 9x cubed plus 3x squared. Oh, and these guys completely cancel because positive 3x, negative 3x, positive and negative 1, right? This is exactly what we had. Now the method over here that I call check method is actually one of the very important theorems that we are covering today, which is called the remainder theorem. In the remainder theorem, right, which is the division algorithm, we can no, sorry, that's not a remainder theorem. It's the way you write the polynomial. It's called division algorithm. Not sorry. So division algorithm. Let's go red. the division algorithm will say that f of x is equal to d of x times q of x plus r of x. And the way the problem is formed when you have the division, right? It will be d of x divided into f of x that gives you q of x plus r of x. That's how they're organized when you do your division, right? So this q of x is called the quotient, which is your result, and r of x is the remainder. Also part of the result. So both of those together, right? So if you divide f of x by the divisor, you will get q of x plus the remainder. To check, you would use this, because we multiplied those two first, and then we flat out added the remainder, and that's how we checked. So that was the division algorithm, which is exactly the same as if you have numbers. Now, what we are going to do is a specific way called synthetic division, which is good only when you are dividing by a linear term. So generally this is something that is like a special kind of rule. You can completely ignore it. I wouldn't recommend you ignore it, because you can save a lot of time in the next section if you learn it very well, because it's way less writing. But it only works if you're dividing by the linear term. So the next topic over here is synthetic division. And I'll put here immediately, works only if we are dividing by linear polynomial. That is very, very important. The method will fail every other way. So let's take a look at this method where we are going to divide, let's say, x, let's divide, let's see if we can find something nice as introductory example, so we don't go immediately with something diabolical. Just browsing through, there we go. Whatever, number 20. So we need to divide 5x squared minus 12x minus 8 by x plus 3. So that's what we are supposed to divide. And the way we do it with the long division, one more time, is x plus 3 into 5x squared minus 12x minus 8. X goes into 5x squared 5x times. That's 5x squared plus 15x. When we subtract, the first one's cancels. Minus 12 minus 15 is minus 27x. And then we have minus 8. And then x goes into minus 27x minus 27 times. Minus 27 times x is minus 27x minus 81. Then you subtract. The first guys cancel. Minus 8 plus 81. That's going to give us negative 73, I believe. Right? Negative 73. No, sorry, positive 73, because minus and a minus gives us a plus. So positive 73. And we would just say, so the answer is 5x minus 27 plus 73 over x plus 3. So this is what we did with the long division, and this is how much you have to write to divide it in a long division. However, synthetic division allows you to do this way faster. You have x plus 3, so in this special box over here, you will put negative 3. We'll explain that stuff later. The polynomial is 5x squared minus 12x minus 8. You will put 5, negative 12, and negative 8. You just put coefficients. So that's the setup. This line over here is the setup. You use same coefficients as in your polynomial. You use same coefficients, so 5, negative 12, negative 8. And for the divisor, you will use, instead of plus 3, you will use negative 3. Now, I am going to tell you that this is a root, right? For this polynomial, root is negative 3. Because when you set this equal to 0, subtract 3 on both sides, x equals negative 3 is the root of the divisor. So you will always be placing opposite sign. You will always be placing opposite sign in here. Now, for the algorithm, I really need you to pay attention here. It's a pattern. Drop down 5, multiply with negative 3 to get negative 15, add down to get negative 27, multiply with negative 3 to get positive 81, and then get your 73 here, and that's the remainder. So, if the first one was x squared, then the first one over here is x. So you have your 5x minus 27 plus 73 over x plus 3, and we did it in a flash. It's very fast, very convenient, it goes really quickly, but you need to know the pattern. So please observe the pattern one more time. You drop the 5, whatever number is here, you just drop it as is on the bottom. Once you have that number there, you multiply and you write that entry there. Then you add, we got negative 27, so negative 12 plus negative 15 is negative 27. So you add down, and now you have the 27. Now you multiply 27 by negative 3 to get 81. You add down into 73, and you are done. So multiply, put it here, add downwards, multiply, get it here, add downwards, and you are done. It's always like that. Multiply, add, multiply, add, multiply, add. Let's take a look at a couple of these examples. I'm just going to make up stuff now. 3x cubed plus 4x squared minus 6 plus 4, whatever, divided by x minus 2. So to set this up, we use the opposite, which is positive 2, and we write coefficients as they are in a problem. 3, 4, negative 6, and 4. So those are my coefficients. All I need to do now is to go through the pattern. So remember, always the opposite sign, always the opposite sign. For these guys, always the same signs. Let's go. Drop down 3. 3 times 2 is 6. Add down, get 10. 2 times 10 is 20. Subtract, add, get 14. 2 times 14 is 28. Add, get 32. And the last one is always your remainder. So, since the first one started as x cubed, the one over here that it's an order of the exponent less has to be x squared. So the answer is 3x squared plus 10x plus 14 with a remainder of positive 32 over x minus 2. Would like to do one more example with synthetic division, and this time I will have some of these missing, and if you have anything missing, you just put the 0 for it. So let's say we have x to the 4th plus 3x squared minus 6 divided by x plus 3. Doesn't really matter, right? Make up anything. You can really make these up and just practice them. We use opposite sign, so negative 3. And now we are going to place 0 placeholders for every term that it's missing. So the highest one is x to the 4th, that gets a 1. X cubed is missing, so that's going to be a 0. X squared is present, that's a 3. X is missing, that's a 0. And then negative 6 on a constant. So you have your x to the 4th, you have x cubed, you have x squared, you have x, and you have a constant. Right? So now we just plow through the procedure. Drop 1 down. 1 times negative 3 is negative 3. Add them up. We get negative 3. Negative 3 times negative 3 is positive 9. Add them up. We get 12. 12 times negative 3 is negative 36. Add them up. You get negative 36. And finally, negative 3 times negative 36, well, negative times negative is a positive. 3 times 6 is 18, so 108. Subtract, we get 102. And that's the remainder. If the first one started as x to the 4th, then the answer starts as x cubed. So the answer is 1x cubed, which is just x cubed, minus 3x squared, plus 12x, minus 36, plus 102 over, what is this? 102, x plus 3. All right, cool. So that is what it's called synthetic division, and it only works if this is linear, meaning first exponent. This problem here cannot be solved by synthetic division because this is quadratic term. Synthetic division works only for the polynomials that are divided by the linear term. Technically, y equals mx plus b, right? mx plus b. So only for this x to the first power, synthetic division works only for that. We will be using synthetic division on our next lecture, which is on Wednesday, for 2.5. Every problem you will have to do synthetic division. For every individual problem, you will have to do 2, 3, maybe even 4, sometimes even 10 different synthetic divisions. So you really need to be proficient with synthetic division to go through that quickly. Now it's time for us to write those two theorems that are important and see those two theorems will be used next class to solve problems in terms of finding roots of polynomials, finding zeros, roots, or solutions of polynomials. That's our 2.5 title, and this would be technically driving the whole deal. So, remainder theorem. It says this: if the polynomial f of x is divided by x minus c, then the remainder is f of c. We will demonstrate that by using an example we had from before, right? So if you go back to, for instance, this problem, how about the previous problem? Yeah, whatever, they were all equally bad. So if you take a look at problem 20, we were dividing by x plus 3. So I'm going to copy this problem So please copy this problem, 5x minus 12x minus 8. And from here, we determine that your x minus c is x plus 3, so c is negative 3. That's that negative 3 that ended up in a box, right, for synthetic division. That's the c value. Okay, so a remainder for this problem should be f of negative 3. Okay, so that's 5 times negative 3 squared minus 12 times negative 3 minus 8. This better be the same value that we have up there. So we have 5 times 9 plus 36 minus 8. 5 times 9 is 45, and 36 minus 8 is what? 28? 28. 40 plus 20 is 60, 73. So remainder better be positive 73. When we did the long division, we did the synthetic division, we better have the remainder 73. Let's go, problem 20. Oh yeah. 73 73. So the remainder theorem helps you compute these values very quickly. Very quickly. Now we'll see how that works next class in a concept of a bigger problem. Right now we just need to know that if we have some kind of division problem, we don't have to divide. We can, we don't have to. So the second theorem, which is the factor theorem, is the one that we are actually using, and the remainder theorem is the one that makes it possible. So this is the big guns now. Oops. The factor theorem. Let f of x be a polynomial. Any order. 7th degree, 10th degree, 2nd order, whatever. Any. Part A of the theorem says, if f of c equals to 0, then x minus c is a factor of f of x, and b, if x minus c is a factor of f of x, then f of c equals 0. Holy nightmare, this is important stuff. Polynomials tend to be one of the nastiest functions to find roots, and this thing saves our life. I will write this as a note. If f of x divided by d of x is equal to q of x with no remainder, then d of x is a factor of f of x. So if it divides evenly, right? If it divides evenly and there is no, if it divides evenly and there is no remainder. So I want to go back to, let's say, problem number 3, so we can put some stuff together over here. We had x cubed minus 2x squared minus 5x plus 6 divided by x minus 3. So technically, I want to know if x minus 3 is a factor. Well, I can do that in 3 different ways. I can do long division, I can do synthetic division, or I can just plug 3 and look for 0 remainder. Those are the 3 ways to do the same thing. So the question is now, is x minus 3 a factor of x cubed minus 2x squared minus 5x plus 6? We can do it 3 ways. Way number 1, long division. Way number 2, synthetic division. if you use any of these two methods, you are looking for 0 remainder. The best method, the fastest method, number 3, is just to say is f of c equal to 0? If yes, then x minus c is a factor. And that's the theorem. So my x minus 3 in denominator is telling me that c is 3. So all I need to do is f of 3. So that's 3 cubed minus 2 times 3 squared minus 5 times 3 plus 6. If this is 0, x minus 3 is a factor, 3 is a root, and that's going to be the next lecture. So I have 27 minus 2 times 9 is 18 minus 15 plus 6. 20 is that's a 9. 9 minus 9 is 0. Yes. Yes. So we can say, since remainder is 0, since remainder is 0, x minus 3 is a factor, and x equals 3 is a root. Needed for 2.5. All right, so now I just want to work out one of the longer problems that are at the end, a little bit deeper into the section. So problem 42, and this would be our final example for tonight. We have a problem 42. It says use synthetic division to divide x cubed minus 2x squared minus x plus 2 by x plus 1 in order to try and find all of the roots, right? So use synthetic division, find all roots. Now, this is something that we should be able to do. Let me just check. X cubed minus 2x squared minus x plus 2 divided by x plus 1. Okay, cool. So this was problem 42 on page 364. All right. Say use synthetic division. So we are using -1. And then we're using coefficients. Now we have cube, square, linear, and constant, so we just copy them. Put the line. Drop down 1. 1 times -1 is -1. Add them. We get -3. -1 times -3 is +3. Then that's going to give me 2. 2 times -1 is -2, and they add into a 0. So no remainder. Which means that x plus 1 is a factor by the theorem we just covered. and x equals -1 is a root, which is one of the roots. Next class, we are going to learn that number of roots in a polynomial is always equal to the highest exponent you have. So we are expecting 3 roots in this problem. We found 1, right? Because remainder was 0. So now we are left with the x squared minus 3x plus 2 polynomial equal to 0 to find the other 2 roots. But this one is easy. You can either factor or use quadratic formula, whatever you like. So if you want to factor this, it will factor over, if you use algebra, right, with the elementary algebra thing, x minus 2, x minus 1. So we have x minus 2 equals 0 and x minus 1 equals 0. So x equals 2, x equals 1. And here we have the roots to be -1, 1, and 2. Now, let's say you care and you want to check. What do? Well, just multiply them all out. Check. What do? You have x plus 1 times x minus 1 times x minus 2. Multiply this and we're good. When you multiply the first 2, well, this is a difference of squares, so x squared minus 1 times x minus 2. Middle terms canceled here. When you multiply this, middle terms cancel because of the, well, I'll write the formula just in case. Let's go blue. A plus b times a minus b is a squared minus b squared. That's the algebra formula that you might have forgotten. And now we have the final foiling here. We get x cubed minus x minus 2x squared plus 2. So that's what we have. And now we have x cubed minus 2x squared minus x plus 2, which matches our original problem. And that's it. So next class, I see one of the questions in the chat. Next class, we are going to learn that the highest exponent, because in this case is a 3, the highest exponent will tell you how many roots you must find. Sometimes some of those roots are complex. You still have to find them. So 3 in this question, 3 in this question, 3, 2 roots. So here's a 4. So this one would have 4 roots because it's to the 4th power. So but that's next class. So we'll deal with that on Wednesday. I will be logging on every Monday and every Wednesday around 6 to teach one of these sections. You are welcome to join and just like today, ask questions in chat, and I will do the best to answer those. Email me if you have anything else, and I also need to figure out what to do with office hours. I am experimenting with Zoom and Microsoft Teams and a whole bunch of other stuff. So once I have that working, then we'll have some office hours in addition to the teaching. I also posted the old list of topics that I covered, I believe, in spring 2017, I believe, or 16, whatever. One of my first lecture series that I had on Precalc. So you can also have a second you can also have a second set of problems there. It's the same topics, even the same sections. So we have 2 more lectures, and exam 2 will probably be on MyMATLAB or something like that. We'll figure it out. We definitely know we're not coming back to campus this semester, because the president did email today the whole college community and said that all face-to-face classes are canceled and commencements are postponed as well. So we'll have to figure out when we will be able to go back. So for the rest of the semester, this is it. We will have to do this this way. So your grades are posted on Canvas for exam 1, and we'll discuss the rest of the stuff. Please keep checking periodically the homework on MyMATLAB, and keep checking for announcements on Canvas. That's the only way I can reach you guys. There is nothing else. I will see you all. Well, I won't see you. I'll see what you type on Wednesday. Bye.